Example number 2. Hey, get on here. I can stick around. Same idea if you have fractions where the denominator is a binomial. Our goal is to get a common denominator. So right now I have an x plus 2 here. I'm going to leave some space. On this side I have a 2x over an x minus 3. And I look at my denominators and I say, are they the same? No. If I wanted to make my denominators the same, this one is missing the x minus 3. So I'd have to multiply top and bottom by x minus 3. This one is missing the x plus 2. So I multiply top and bottom by x plus 2. Can you see they have a common denominator now? That both of these fractions have x plus 2, x minus 3. So if you were to multiply both sides by x plus 2, x minus 3, they would just go away. In other words, if this fraction equals that fraction, and the denominators are the same, well then the tops would have to be the same. The numerators would have to be the same. So what do we have? Well, on this side, if I distribute, I'm going to get negative 3x plus 9. And on this side, I'm going to get 2x squared plus 4x. What kind of equation is this? We have a quadratic equation. How do you solve quadratic equations? Make one side equal to 0. So you add 3x to both sides. I got 2x squared plus 7x minus 9. Can we factor this? Well, if we could factor it, would you agree that the only option for the first one has to be 2x and x to get the 2x squared? So now we have to check if there's a way with 9 that we can make our outside and inside equal to 7. Now with 9 there's not that many options, right? It's either 3 and 3 or 9 and 1. So yeah, some of you are like already figured out it has to be 9 and 1. But the 9 and 1 makes a difference. Like I have to put the 9 here and the 1 there. Because if I put the 9 on the outside one, then I would get 18x. But right now my outside is 2x, my inside is 9x. I need a plus 7x. So I would want my 9x to be positive, my 2x to be negative. Multiply it all out in your head to double check. Do I still get the minus 9? Yes. So now, solutions, x could be negative 9 over 2, or x could be 1. What are your non-permissible values? In this equation, x couldn't equal 3, and x can't equal negative 2. So that means both of those aren't non-permissible values. Both will work. Part B. Again, I'm going to leave some space. I'm going to rewrite it, x plus 2. That's grouped together. And on the bottom I have x minus 5, and that'll be grouped together. And leave some space with my equal sign. And on the other side I have x over an x minus 1. Are my denominators the same? No. What's this one missing? An x minus 1. What's this one missing? An x minus 5. And once you have the denominators the same, you could multiply both sides by this, which would get rid of that completely. Now on the left side, if I simplify by multiplying this out, I'm going to get x squared plus x minus 2. Have to FOIL that out. On the right-hand side, if I multiply, I'd have to distribute that x. I would get x squared minus 5x. Are you okay that I multiplied and combined like terms all at once, like x times x is x squared. 2 times minus 1 gave me the minus 2. My outside was minus x, my inside was plus 2x. That's how I got the plus x. So all of that work with factoring and multiplying things out, now it's coming back that you can do it a little bit faster. You can write out your answers quicker. In this one, it's a quadratic equation, so we move everything to one side, and something beautiful happens when you move it to one side. You see that your x squared, when you move it over, cancels out with the other x squared? Very nicely. And I move the 5x over, I would get 6x minus 2 equals 0. And I moved it over to equal 0 because I saw a quadratic equation, but now the quadratic equation's gone. So now I just need to solve for x. So I would probably move my 2 over and divide. I'd get 2 over 6, which reduces to 1/3. What are my non-permissible values? In this equation, x can't equal 1 and x can't equal 5. So is this answer okay? It is. The next question looks kind of exciting. I snuck a peek at the answer, and the answer looks exciting. How is this going to happen? So we have 7x minus 15. That can't be factored, so I group it together. I have an x squared minus 9, which I'm going to factor to begin with. X plus 3, x minus 3. So just like adding, subtracting, multiplying, and dividing, we always want to factor first. We choose not to factor first. Sometimes we can cause problems. Equals. And on the other side, I had x minus 2, which would get grouped together over x minus 3. Are my denominators the same? No. What's missing? This one needs an x plus 3 and an x plus 3. I'm okay with the red. I wasn't okay. I wanted to save my red for this. Oh, something about canceling it out if a red lightsaber seems like the proper thing to do. So that I can multiply both sides now by x plus 3, x minus 3. That will cancel that out. And what am I left with? Well, I've got 7x minus 15 equals, and I multiply this side out, and we get x squared plus x minus 6. Quadratic equation. How do I solve quadratic equations? I make one side equal to 0. X squared minus 6x, and this will be plus 9. Can we factor? Yes. Factors nicely to be x and x, 3 and 3, and both of them negative. So you get the same solution twice, which is x equals 3. What were our non-permissible values? They were negative 3 and 3. Uh-oh. So our answer is actually a non-permissible value. So it is not allowed to be an answer because it wasn't allowed to begin with. And since there is nothing that's allowed, this question has no solution. There's no x that will ever work to make these things equal. That's cool. Kind of disappointing that you spend all this time trying to solve something only to find out that there is no solution. Like, maybe a little bit angry at that. But the no solution is the solution, so technically we've still found the solution, but there's no number that makes it. So we always have to check our non-permissible values at the end to make sure that none of the answers are those non-permissible values. Oh, I like that question. Okay.